Hello, my name is Kirsty Halloran. I've made this video for two reasons. Firstly, I'm a member of a Facebook group, Irish Solar PV and Battery Systems Owner Group, and I've been requested by a few people there to share a model I created to help to work out the best electricity plan. This is something that I had done in Excel. The second reason that I'm making this video is I watched a prime time on RTE on September 22nd. It was an interview with the chairperson of Commission of Regulation of Utilities, and it created quite a lot of comments in our solar PV and battery systems owners group. And I was quite animated about the piece myself because it completely downplayed the complexity of this area for consumers. I felt actually that some poor advice was also given to consumers on the show. So I wanted to address those 2 points. This video is divided into two sections. Section one are things to watch out for when picking an electricity plan. And here I've also shown the samples that I've used in the model, which will be in the second half of the video. Also, I have a call to action. I'm asking that people please sign a petition to the Environment Minister on transparency and consistency by energy providers about standing charges and how they present tariff information to consumers. We'll talk a bit about that in a moment. In the second section of the video, we'll review and I'll explain an editable Excel spreadsheet that I've built that will help you to compare energy plans. This file can be downloaded and you can edit it as you wish, adding extra sections or changing whatever you will and improving it. I'm not in any way claiming to be an expert on this, but what I created certainly has worked for me, and hopefully it might give you some good ideas too. And just lastly, before we kick off, I don't have any connection to any energy companies. I don't work in the area of energy provision in any way. My LinkedIn details are actually in the bottom right of the screen, just to show I'm not in any way connected with this industry. I am simply a consumer who's been a bit frustrated going through the process and is looking to see if I can help other people avoid some of the pitfalls that I found myself. Now, I certainly don't intend on going through all the electricity plans that are available, but just to give you an idea, the first provider I looked up offered me 16 smart plans, so that's certainly a lot of choice, but obviously a massive amount of complexity as well. On the screen at the moment, you can see three plans shown. Two are smart plans from the previous page, and one is just a standard new electricity if you were to move to this provider. But before we look at the two smart plans, I think it's interesting to listen to what the regulator has to say about this.
But if you are a household or a business where you can shift some of your load off peak, and by that I mean washing machines, dishwasher.
Sure, but I'm just talking about the standing charges. How can you, as a regulator, stand over standing charges on a smart meter, which is about encouraging people to cut down use, be more expensive than on an older system? How can you stand over that?
So I'm not aware of particular differences between the standing charge on smart tariffs versus standard charges. Well, because they're competitive offers by all suppliers, so there's a range of different offerings on the market, and typically what they're competing on is actually the unit charge. So what they're offering are different unit charges across day, night, and peak. Some of them offer free Saturdays or free Sundays, so there's different options.
Yeah, but then they charge you more for the unit price, and it ends up that you're probably not saving much.
Well, I think a lot of people are saving money, and a lot of people can save money. A lot of what they need to understand is their own consumption pattern.
So the regulator has said she's not aware of particular differences between standing charges, and that typically what providers are competing on is the unit charge. So thereby we're directed to look closely at the unit charge, which is what we'll do now. If we start on the left of the screen, we can see day units of 24 cent, peak units at 29 cent, night units of 17 cent. And then in the second plan here, we can see day units of 22 cent, which is lower. Peak units are a little bit higher at 31 cent. We see night units lower at 16 cent. And then we see this amazing 5.7 cent for an EV rate at night. So this makes this plan look particularly attractive. If we look at the third plan here on the screen, this is 29 cent, 24 hours a day. So clearly we can see that this one is definitely the worst of the three. If we do as we're encouraged to do, and at face value we look at the price of the units, we could very well be tempted to believe that this second plan here might be optimal for us. But what we do need to look at is the standing charges for these plans. Looking at the first smart plan we looked at there, we can see there's a standing charge of €281.12 for the year. If we then look at the second plan, this was the one that had that 5.7 cent rate for a period during the night. We can see here the standing charge for this plan is €418.78. So big difference there. Just to give some context, the standing charge for this particular plan is €137.66 higher than the first smart plan we looked at. If we were actually to work out what we could have bought for that €137.66, it would be 2,400 units of electricity at the EV rate at night, or 614 day units. So just to put that in a bit of context, in terms most of us understand being Irish, we all have a fear of leaving the immersion on. An immersion typically runs at 3 kilowatts. If you had 614 day units available to you, this would be the equivalent of being able to run your immersion to heat your water for about 200 hours. So this obviously, changes things significantly. And then you start wondering, can I really get the value out of that cheap rate at 5.71 cent for that period during the night if I've got to pay this much more on the standing charge? This is actually the plan that I am on myself. The standing charge wasn't €418 when I signed up to it earlier in the year. It was a lot lower. As far as I recall, at the start of the year, it was about €250. At the end of April, I signed up and it had gone up to €320. It's now at €418. And what I'll do when we look at the model in a bit is I'll show you why I picked this rate and how this rate works so well for me. Another thing to carefully watch out for is the number of hours you get on this EV rate. This particular plan here, the EV rate is from 2 a.m. to 5 a.m. So that's 3 hours. However, some of the other providers who offer an EV rate offer it just for 2 hours at night. And that actually is an important difference. So you're often not comparing like with like. You do need to check and see how many hours you're being given at this EV rate. This is another very interesting smart plan. Free time on Saturday. When I saw this initially, I was very interested and thought, maybe I could not run the washing machine and dryer all week and then basically spend Saturday doing laundry. The standing charge on this one also €281.12. When I started looking into the terms and conditions of the tariff, I could see there's a fair usage cap on this free energy units. And there's a monthly allowance associated with this. This cap is set at 100 kilowatts per month. 100 kilowatt hours per month works out at 1,200 kilowatt hours per year. Divided by 52 would be about 23 kilowatt hours per week. You'd be aiming not to use much more than 23 kilowatt hours on your free Saturday to ensure that you didn't run into the charged energy units. So I very quickly ascertained that wouldn't work for me at all, because if I did one wash and one dry and the background load in the house on a Saturday, I would already be above the 23 kilowatts. Sometimes these offers look great, free time Saturday, but it's a limited amount of free time Saturday or Sunday. So that's another variable you've got to consider when you're looking at these plans. You've got to look behind the titles all the time. Sticking with this same provider, a non-smart meter plan, this is their standard 24-hour plan. The annual standing charge is also €281.12. This has a per unit cost of 29.76 cents. So without doubt, with this particular provider, you look better to be on a smart plan, but there's a lot of variability within the smart plans. For this particular provider, they didn't seem to have a pure day-night plan based on a day-night meter. A lot of people want to hold on to their day-night meters because they feel they're getting better deals on those than with the smart plans. And just moving on quickly to look at one other provider, here you'll see the idea of getting a €250 welcome credit or an e-store gift card. €250 definitely a welcome amount, but again, it's another variable you've got to look to understand. And also up front here, you don't see the tariffs. You're going to drill down to another level of detail for the tariffs, which I'm showing now. And you can see again, you're looking at a fairly reasonably complex table. And in here, one of the things I noticed was that two prices were being quoted, including VAT and ex-VAT. So then I started questioning, well, what have I been looking at on the other plans? Did they have VAT included or not? Also here, there's variability in terms of urban and rural divides. Also here, you'll see a completely different format of information to what you saw with the last provider. So if you're making your way provider by provider through all of this data, which looks different and is displayed differently on each website, it does become challenging. Let's just wrap up by listening to a last portion of the interview on prime time with the regulator on this whole topic of electricity plans and smart meters.
But I'm just thinking that 1.2 billion is being invested in this, and what you're saying tonight is it's up to the consumer to get it right. Is it not up to you as a regulator and to the providers to be made get it right?
So when we started the smart metering program, one of the key, I suppose, purposes of it was to provide more information and better options to customers. And we can save for individual customers by saving on their own bills. We can save more globally on the system by reducing the need for new generation capacity, and we can invest more wisely in the networks. So there are definite advantages to this program, but as we worked through the process, and particularly with GDPR requirements, it became clearer that actually customers need to opt in. It's really important
But
for
how
them
much
to be
homework
making
is
choices.
the average consumer going to have to do to get it right and find out what they need to do?
Yeah.
Let's try and answer that prime time question. How much homework is the average consumer going to have to do to get it right and find out what they need to do? I wanted to actually work out how many variables you could be looking at when you're picking a price plan for an electricity provider in Ireland today. Based on the information that I looked at when I was putting this content together, you've basically got time of day rates. There are 4 typically. You've got standing charges. You've got feed-in microgeneration payment. That's very important to any of us that have PV panels on our roof and are producing electricity ourselves. Plans per provider, there could be up to 17. As I showed, the first provider that I looked at had 17 smart plans. The number of providers up to 9. When I did a quick Google, electricity suppliers in Ireland, these 9 came up. If you multiply these out, the 6 variables, the 4 rates and the standing charge and the feed-in, multiplied by 17 plans, multiplied by 9 providers, you're potentially up to about 1,000 variables there. And I know you might say, well, realistically, not all providers have 17 plans, and you probably wouldn't look at all providers. But other variables that I didn't include in that calculation include urban rural meters, e-billing discounts, direct debit discounts, prices, whether they have VAT included with some providers or don't have VAT with other providers. So I think it's reasonable to say we're definitely at hundreds, and you could calculate, I think, well above 1,000 variables that could be in play here. So it's certainly not easy for consumers to make informed decisions on this. So my call to action on this, I started up a petition. I'd appreciate if you signed the petition. The link is in the description and shown there below, to the Minister for Environment, Climate and Communications, to provide a consistent template to electricity providers for displaying their price plans, including items such as standing charges, hours of day in each tariff, whether prices are displayed with or without VAT, and so on and so forth, because a consistent template will make it much easier for consumers to compare offers. Secondly, what I'd like to ask for is a consistent approach to standing charges, both within provider plans and across providers, so that consumers have less variables to compare making decisions, and therefore can focus on their usage, which they need to understand, and on the time of day tariffs that are offered. If you do agree with the content as laid out in this video by me, I'd very much appreciate if you sign this petition. The link is in the description and shown there on the screen. Thank you. Next, we're going to move on to take a look at this Excel model that I developed due to the complexity of this whole area. So let's kick off. As you can see here, we've got an Excel spreadsheet in front of us. What I've done is I've tried to lay out a series of fairly simple questions to help you step by step get to finding out which might be the best plan for you. The questions that you're going to answer are on the left of the screen, and there are some help files or prompts for the questions on the left over to the right. So one of the most important things, or possibly the most important thing, is to know what your own consumption is like. So we're going to start off here with question 1. So you need to know how many units of electricity you're using in a year. There's a few different ways of finding this out if you're not sure. So I've given you a few options to the right. So, you could add up your units across your electricity bill for the year. If you don't have access to all your bills, you could take a March or October bill as a reasonable estimate of usage, as these straddle summer and winter. So you could take maybe one of those and multiply it out by 12. If you've got solar panels, you should have an app that gives you quite detailed information, and you may have day-night meters, which will give you even better information. So like I said, first step is to work out what your overall usage is. So I know for myself that I use 9,610 kilowatt hours over a period of a year. This was on a standard meter, so I couldn't tell from that, which was daytime, which was nighttime. But I do know that obviously I did have a background load running in the house. And I happen to know from my app that my background load is around 600 kilowatts, 600 watts per hour, which is reasonably high next to a lot of people I know. So from what I hear, people tend to be somewhere between 300 watts and 600 watts. I have 2 fridges. I have a mechanical heat recovery system. I've got radon fans. I've got security cameras. So that explains why I have quite a high background load. If you have like one fridge and you are good about switching off things at night and you don't have a lot running, you might have 300 background load. So what I would say is pick somewhere between 300 and 600 as your background load. You've got a little calculator here which can help you with that. As you can see, you can just plug in 300 or anywhere, any number you like, and it'll give you your background load. So I've got a background load there I'm assigning for myself of 1,971. So this is an amount I know, roughly that I'm using at night. And then basically you're deducting your night units off your total units to give your day units. But I'm actually going to stick a couple of units in peak as well, because I know myself, even though I have a battery, running the house between 5 and 7 every day, every month I end up with a unit on the bill. So when you turn on something like your oven, even if you're using a battery, what I find is there's a quick draw from the grid when the battery's kicking in, and all these little bits and pieces add up to a unit. So I'm sticking in 12 units there anyway. And then what I can do is, if I take my total amount, which I said was 9,610, and I can take away, I'll take away the 12 and I'll take away the 1971, and there I get 7,627 as my day units. And again, this is just a verification over here that the 3 numbers I've plugged in add up to 9,610. Now these numbers are going to be carried through to question 2 and to the final area where the numbers are pulled from further down, which is question 6 here. But you're going to be asked a series of questions on the way down to see what adjustments you want to make to those. So if you didn't make any other adjustments, they'll just be carried straight down. But the next question we're going to look at now is, can some of these units consumed during the day, can they be moved to nighttime? So I've given some tips over here on estimating what you can move over on the right hand side of the screen. So things you could consider is, how many times per week do you run your dishwasher? A dishwasher is about 1.5 kilowatt hours. How many times a week do you run your washing machine? A washing machine is about 3 kilowatt hours. So if you run your dishwasher every day and your washing machine 3 times a week, that adds up to roughly 1,000 kilowatt hours per year. So you've got the potential to move that to a nighttime or an EV rate, 1,000 kilowatts per year. So what I'm going to do is, we don't know whether we're going to use EV units or not. So I'm going to actually put them in night units, and I'm going to increase this here. I'm going to write over this number. So where I have 1971, I'm going to put in 2971, and I'm just going to decrement these day units by 1,000 as well, so they would be 6,627. So what I've done there is I've just said, okay, I'm going to move some of my units from daytime to nighttime, about 1,000 units. So the next section here, section 3, is, if you're considering moving to a smart plan, you might choose to move something running on a fossil fuel to electricity. So for example, a car, your water, something like that. So for me personally, I have opted to move my heating of my hot water from kerosene to electricity. I managed to get a fairly good estimate of how many litres of kerosene I'm using per year to heat my water, and my estimate is 400 litres of kerosene per year. And if I go to oilprices.ie, at the moment in Galway, it gives me €1.23 is the price per litre. So if I stop using 400 litres of kerosene in a year, that's €492 that I won't be using on kerosene anymore. So this section here, what it's looking to do is to estimate if you go on specifically an EV plan with a couple of hours of really cheap electricity, what could you move and would it be worth your while moving? So the second area here, I've got just a few. You can edit these headings. I put in a few that I thought of. So next we want to say, well, what electricity would I be consuming, to make up for what I'm giving up? Or if I'm buying a new electric car, for example, I'd be adding that in there. My element in my tank, I think a 3 kilowatt element, but I've monitored it and it seems to only be able to take in 2.8 kilowatts per hour. So I've got 2.8 kilowatts per hour for the hot water. The maximum capacity, this isn't actually in the calculations, but it's just to guide you through using this section, that I know my hot water tank, it can take about 13 kilowatts before it heats, before it'll say it can't heat anymore. So if I've got 2 hours at an EV rate at night, that's 5.6 kilowatts I can get in. Whereas if I have 3 hours, it's 8.4. Now this is very significant with hot water, that this extra hour makes a big difference to the heat of the water. I don't have an electric car. If I did, I think that's roughly around 7 kilowatts you'd be putting in there. I do, however, have a battery. I have 2 batteries and they can take input at 2.4 kilowatts each, I think. So that's 4.8 kilowatts I could put into my battery at night. The maximum capacity of my battery, usable capacity, I think is 10.9, but I'm going to put in 10.5 because I usually don't fully discharge it. So with 2 hours of EV power, I can get to 9.6, which is close to full, right? I certainly can't fit 14.4 in every night because it doesn't have that capacity. So I'm just going to write over that 14.4 and put in 10.5 because that's the highest max capacity I can get to. And so what's this is calculating out for me here is it's saying, per night on an EV rate, I could, I could look to consume 7.6 kilowatt hours of power per hour. And if it was 2 hours, it would be 15.2 kilowatt hours, or 3 hours, 18.9 kilowatt hours. And I've got the calculations there, which again will feed back down into the table below when we get there. And now we're at the last section before we go and look at the provider side of things. So if you're a micro generator of electricity, here you're going to estimate your energy production and when you use the production. If you're not a micro generator of electricity, just leave this section here at zeros, and the units from above will automatically be brought down to this orange panel. I have PV panels myself, and with the year of data that I collected, I could see I had generated 6,189 units. Now of those units, I know 700 of them went back to the grid from my app, so I'm going to plug those 700 in there. What I also know is that even though all of that electricity was generated during the day, it wasn't all consumed during the day. So the night rates kick in at 11 p.m. at night, so I needed to create an estimate of the amount of power that I would have used from my battery in the evening time. And this will vary a lot from person to person. My calculation was about 360 kilowatts of that I had used, in the evening time. And so then that leaves me with, out of the 6189, if I have 6189, if I subtract the night units and I subtract the grid units, I've got 5,129 units. So that's the amount of units that I believe roughly that I generated during the day and used during the day. There's my 6189 check. What you can see now down below here is that my day units have been decremented. So this is what I want to buy on my electricity plan. So I've decremented my day units. The peak units have stayed the same. My night units I've decremented by 360. No change to EV units because we're dealing with them separately up here. My total units that I'm looking to buy is down here at the bottom. So scrolling down now to the provider section, which is where all this information comes together. So what I've done is I've put the data in for the 5 plans that I had discussed in the earlier part of the video. So what I'm going to do is just from right to left, just explain to you how this calculation is working. So here, the first one here is the Bord Gáis Smart standard electricity plan. So you've got your standing charge you key in here to start with. You put in your day unit price. Your day unit price will automatically be copied across to peak unit price until you change it, because obviously you have to have something in all of these. You have to have something in peak, you have to have something in EV. So if there's no peak or EV, it will copy across. So for example, if I just put 7 down here, you can see it's copied 7 across. Or similarly, over here, if I put a number in here, it'll copy across to EV. So the reason for that is just to make sure that all 4 cells are populated. So if you don't put in a specific peak rate, it's going to assume the peak rate is the same as the day rate. If you don't put in a specific EV rate at night, it's going to assume the EV rate is the same as the night rate. So this first plan here, we've got the standing charge, we've got the day unit charge. Peak unit price is higher. You can see there at 24 to 29 cent. We have a night unit of 17 cent and the EV also 17 cent. The reason for this is they don't have an EV rate. So all through the night, you're going to be paying the 17 cent. This little calculation here, this section here is the section where we filled out above. Is there anything you're going to move across from something like a fossil fuel? So it's a nested if statement here. And basically what I'm asking you to put in is 0, 2 or 3. 0 means there's no EV hours. 2 is 2 EV hours. 3 is 3 EV hours. 2 and 3 seem to be the standard at the time, which is why I picked these. You can obviously overwrite these, edit these as you wish. So if I were to put in 2 here, it'll pull down 5,548 units from above. This particular one is 0. I'm putting in 0 because there's no EV rate. Okay, and again, if we just go down a row here, and you can see where I've put 3 in, this is on an EV rate is 3 hours, and you can see the 6898 comes from up here where we calculated the 6898. Okay, welcome credit. So some of the plans have a welcome credit. So for example, this electricity one at the bottom here has a welcome credit 250 euros. So I put that in there. Free day units within the month. So this is another category of plan, a free Saturday, a free Sunday. So this particular plan here, free day Saturday, it has zeros everywhere else, but you can see here you can get up to 1200 kilowatts per year. The feed-in tariff is next. This is the feed-in tariff you get for selling back your electricity to the grid. If you don't have panels, you're not going to get anything. But for those of us with PV panels, we're interested in this. And again, I've put in 18.5 cent for the Bord Gáis rate here and 14 cent for electricity, which it was at the time of making this video. So next then we've got my consumption units. So my consumption units are coming down from above here, from this panel here. You'll notice this one is lower here on the electricity one, and the reason it's significantly lower than the others is that we factored in, I factored in, if I went on this Saturday plan, free Saturdays, what would this mean for me? And I've estimated usage at 0.9 that I would manage to get, 0.9 of the allowance used, because sometimes I'm sure I'd mess up on a Saturday where I might be away on holidays or something like that and not get it quite right. Peak units, night units, EV units, all at 0. My feed-in in kilowatts, this 700 kilowatts has come from up here from this panel where I've told it that I've generated 700 units for feedback. So then we've got the calculation of my day unit costs, my peak unit costs, my night costs. My EV costs are on 0 at the moment because I'm assuming that, you know, I haven't made any plans to move across content. But then what I have here is if I do move to an EV rate, I've separately done this calculation here, which tells me that it would cost me €393.90 to move this content here for 3 hours to an EV plan. So this is up here if I choose to move my hot water and charge my battery. I've got this extra spend I'm considering, and this would come in at $393.90. I've got my feed in that I'm going to get paid from the provider. I've got a first cut at an annual electricity bill. Then what I have over here is my savings from question 3. So if I decided I was going to, you know, as I did, stop using kerosene and move to electricity, I had that €492 savings from above. So you'd recall I'm going to spend €393.90. I'm going to stop spending €492, but for that €393.90, not only am I going to get my hot water, I'm also going to get my 10 kilowatt battery charged every night. And then this final value here is basically, you know, the annual electricity cost minus any welcome credit, minus my feeding gains, minus my savings. So I only have the savings included here if you're on an EV plan, because you wouldn't be doing this otherwise. Just a couple of other things to watch out for. When you're putting in your EV rate, a mistake that I consistently make is I put in 0.571 instead of 0.0571. So if you're looking at EV rates, make sure you put that 0 there or you'll completely mess up your calculations. That's something to watch out for. Something else then, if you had gotten to this stage where you said, you know what, this EV plan is definitely going to work for me, which was the case, you know, with myself, right? What you can at that point do is sort of say to yourself, okay, I think I'm definitely going for this plan, but actually that 1,000 kilowatt hours I moved for my dishwasher, my washing machine, I moved it into the night rate initially because I didn't know if I was going to go for an EV rate. But now that it's looking like I'm going to go for an EV rate, I'm going to go back up and I'm going to move that 1,000 units. You'll recall I had started off with the night units of 1971 and I'd moved those up to 2971, saying I was going to put the dishwasher or the washing machine on at night. Whereas what I'm going to do now is I'm going to put that back to 1971 and I'm going to move that 1,000 over here, so that basically it's running just at night time. Just in the 2 a.m. to 5 a.m. So it's running just in the 2 a.m. to 5 a.m. slot. And if I go across here now, I'll see that my I've got a new set of EV costs coming in here now. Yeah, some of them are going to be based just on a night rate because there isn't a particular EV rate and we put the same rate in for both. But if we look at this plan here, yeah, which is actually the plan I'm on, when I move my dishwasher or my washing machines into the EV rate on that plan, yeah, this brings this down further again. So you can see, you know, if you can maximize those 2 hours during the night and get some big heavy hitters in there, like your water or an electric car or your battery, you really stand the chance of making, significant gains. Another thing to consider with the EV rate that doesn't have a huge impact, but you'd recall earlier on we were talking about the background nightly usage when you were asleep in bed, and we were, making this calculation based on 9 hours in the night. If we actually take a look and say, well, for the EV hours, if I'm on an EV plan, how much background kilowatt hours will I use? So for 3 hours a night at 600 watts per hour, so from 2 a.m. to 5 a.m. for me in the year, that would be 657 kilowatt hours. So what I can do, you'd recall I moved the 1000 for my dishwasher and washing machine across. I can also move this 657, so I can increase that to 1657, because the house is going to be running on the EV rate for that period of time. And then I can decrement this one, also the night rate, by 657. And again, what we've done there is we've moved more units to EV. And if I check and see then what does this actually mean for my bottom line, there'll be some more gains again there. We see it's gone down another big chunk with that. On the flip side, there's going to be times like Christmas Day, you're probably going to use, 10 kilowatt hours at peak. We're never going to get this perfect. So what you could do is throw in, at peak, throw in a bunch of units, throw in a bunch of other day units. This is intended as a guideline to try and work out, with all things equal, with your best effort at calculating your usage, what plan will be best for you. I have locked some of the cells just to try and make it easier for people so they know which cells to edit in this spreadsheet. But I always put the unlock code up here in cell A1. It's just PV is the password, so you can just unlock it if you're good at Excel and you're not worried about damaging anything. Just unlock it. If you want to change any of the formulas, obviously fire ahead. It's not an exact art. There's so many variables there. You're never going to get it exact, but hopefully what this gives you is some ideas which will help you try and make more informed decisions with the complexity that we're faced with making these decisions. You can add as many plans in there as you like. This data was just used at the time of making the video, but as we all know, the data is changing constantly. In fact, I think it's changing again tomorrow is the 1st of October. So whenever you are going to refresh your plan, you can hopefully go back to this or your edited version and include stuff. There is no right or wrong answer in terms of which is the best plan in general. It's which is the best plan for me as a consumer, and knowing your own usage and then plugging this information into something like this can help you at least stack rank the providers and make a more informed choice. So I hope this has been useful to you. And as I had said earlier in the video, in the description, there's a petition that I have started up to the Minister for Environment. I'm hoping that we can get more consistency in the display of information for price plans and also some kind of a standardization on standing charges. Thank you for your time, and I look forward to us all working together to make better simulation models and also to help improve the landscape of the electricity market for all users.